been a while since I looked at 3D printers. I'll get into why in a minute, but today I'm going to be looking at the printer that's been my daily driver for the past 2 months. The FlashForge Creative 3 Pro, comparing its output to commercial 3D printing services from my friends at JLC and comparing the results in my new tensile string testing machine. As most of you know, I no longer work with Creality 3D. We parted on good terms, but there were issues with engineering and quality control that I could not be part of. I could not in good faith continue to endorse their printers, which is okay. Companies evolve and make trade-offs and have to figure out how to maintain and grow their profit margins. Or that's over my head. I'm more an engineer than a businesswoman, so I can't really second guess those sorts of decisions. In fact, I'm a pretty lousy businesswoman. It's just not something I'm good at. But I can walk away from what I feel are bad engineering and quality control decisions. So I did, and I'm glad to say there are no hard feelings. I've been taking a bit of a break from 3D printer reviews because there was nothing really that interesting or innovative being offered. But recently, FlashForge offered me this Creative 3 Pro to take a look at. And rather than do the usual unboxing and off-the-cuff review, I decided to change things up a bit and use it for a few months first, just so I could really give you a better idea of what I thought of it instead of the usual initial impressions. To begin with, the first thing that makes the Creative 3 Pro noteworthy is it's an IDEX printer or independent dual extruder. Basically, it has 2 hot ends that can be used separately or mirror each other. This means you can print in 2 materials, or you can mirror print and print 2 of something in the same time it normally takes to print 1. In the real world, IDEX is a lot more useful than it sounds and much more practical than other dual hot end setups. The second feature that drew my eye is it's fully enclosed with an all-metal hot end, so it can print specialty engineering filaments like nylon and polycarbonate. Most of you know I do a lot of structural prints, not much decorative stuff. So those materials have a lot of appeal and are what I want to show you first. What I'm going to do first is some string testing. I'm going to print several small test pieces at 100% infill in nylon, polycarbonate, PETG, and PLA. I'm going to compare the strength of those to the output on my friends at JLC's professional 3D printing services done on big industrial machines. One set printed in PA12 nylon and another set printed in SLA resin 8000. The nylon and polycarbonate filament come from FlashForge, but the PETG and PLA is of course from Polymaker. I pretty much exclusively used Polymaker filament in all my videos for all my 3D printing. It basically had the best balance of cost and quality in my opinion. Most of you probably recognize these models from CNC Kitchen's fantastic series of videos where he tests the strength of different filaments. If you don't, you should definitely follow his channel. I was able to barter and get this used tensile string tester for a few extra 3D printers I had. But it's a lot smaller than his and can only hold about 100 kilograms. So I've scaled all my testing models down for it. Let's see how all these different filaments stack up. Because it's a hook, we are basically testing stiffness. Line-on came out loudest just because it's the most flexible, not because it's actually the weakest. Still, for some applications, we need that combination of stiffness and strength. And it looks like polycarbonate is the right stuff for that usually. Although the JLCPA12 print is far higher resolution and more detailed. We'll get into print quality next time. I'd say polycarbonate for purely functional prints like this, PA12 if they really need to look nice also. You are giving up very little performance for the quality difference. But as I said, don't get the idea that the Creator Free Pro is representative of what it's normally like printing with engineering filaments. I found it much easier to do on that machine. Okay, I'm going to have a quick interlude here to show you how his set inserts work. This is Tinkercad. It's still my favorite application for speed. This little project box took me 8 minutes, and then I passed it over to the FlashForge slicer, Flash Print. You can use most open source slicers with the Creator Free Pro, but I actually like Flash Print for simple stuff. The default settings are pretty reliable, and again, I like speed and simplicity. I don't like dialing in custom settings for each print. This is duplicate mode. In this mode, each head of the printer prints an identical part as the other. So you can print 2 parts in a time of 1. I'm going to add auto support. And then just remove the extra support from the screw holes to save me the hassle of digging it out. Okay, and all default settings. If it's not broken, don't fix it. Slice. And add brim, probably doesn't need it, but it's only a few extra seconds. The printer does have built-in Wi-Fi and it works very smoothly. You can also manage multiple printers on the network. And there is a built-in camera so you can also monitor and control the print process remotely. In general, the best 3D prints are multi-part prints. It's like wood. Carving something out of one solid piece of wood is generally not the best idea because the grain influences the strength and surface finish. Same thing for 3D print layers. So just like wood, it's often best to make them out of a few pieces and attach them. That can be with dovetails or dowels and glue, or it can be using screws in a few different ways. This is how we put a heat set insert into plastic. If you have a more steady hand than I do, you can also just do this with a normal soldering iron, but I prefer this too. I'm also a show off. Sorry, this too is from Taobao, but I'll put some DIY ones in the description. CNC Kitchen sells heat inserts that are actually better than these. I'll put that link in the description also. And there we go. Just a simple little project box, but it's very easy to take apart and put back together as many times as you need. Okay, honestly, those numbers are about what I'd expected. Polycarbonate is really looking good as an engineering filament. I'd say only go with nylon if you need some give to the print. And as before, if you need both optimal quality and strength, PA12 from JLC is coming out ahead. Now, SLA 8000 is about as strong as PLA, but the thing to remember is it's very low cost compared to PA12. And PLA is plenty strong for most things, so SLA 8000 is a good default print material for when you place orders with JLC. It's what I've been ordering a lot of stuff, and yeah, it's basically SLA quality with PLA strength at a very low price. You can check JLC site for current prices. Now obviously, nylon has way more give to it than any of the other plastics. So let's filter that out and compare the rest. And yeah, PETG, known for having a little give, which makes it ideal for drone bodies and stuff. Okay, I'm going to leave it at that because this is going to be a multi-part series, kind of head-to-head, high-end home FDM versus additive manufacturing services. I want to demonstrate what exactly IDEX can do in terms of mirrored prints and prints with mixed filaments, and that's a whole video of its own that I don't want to rush. I think the most important takeaway here is that we are at the point where we aren't stuck with ABS and PLA. There are some extremely strong engineering plastics that, while not quite as easy to print as PLA, they aren't like they used to be, requiring days of dialing in and careful handling and all sorts of nonsense like that. If you have a high-end printer like the FlashForge Creator 3 Pro, you can just pop them in and go. And if you don't, you can get prints done with them for cheaper than ever at JLC. Next time, we'll compare print quality, layer height, and material options. If you have any specific questions about either the FlashForge Creator 3 Pro or JLC 3D printing services, please ask in the comment section and I'll be sure to cover them in that video. Until next time, remember, if I can do it, anyone can do it.